Hello everyone, my name is Mark Kokoropoulos. I'm currently a junior at Hillsdale College. I'm majoring in psychology, and today what I want to discuss with you guys has to do with two of the most popular people groups in the world. On one side we have mothers, and on the other side we have babies. So I'm not really sure that anyone in this room has a problem with this people group. Everyone loves babies, everyone loves their moms, and today what I want to discuss is actually something that happens prenatally. What I want to discuss in particular is something called prenatal stress. Prenatal stress is defined as a low or negative quality of life while pregnant for the mother. And this can manifest itself in a variety of ways. It can look like low income, low socioeconomic status, poor marital status, all those things, even poor psychological health, can all be attributed or just put under this umbrella of prenatal stress. It's not quite the same as something like physical abuse or trauma or even mental illness. Those things have their own separate categories. Prenatal stress is just this fairly general thing attributed to these, poor circumstances or a poor life situation for the mother. And the reason I want to talk about it and discuss it with you guys is because it's been linked to several different psychological disorders and offspring exposed to prenatal stress. To name a few, autism spectrum disorder, attention deficit hyperactive disorder, and schizophrenia have all been linked to prenatal stress in some degree. On top of that, there's different neurodevelopmental abnormalities present in fetuses exposed to prenatal stress, as well as different physiological abnormalities in offspring as well. So I kind of want to give you a big overview of that, just generally how we should tackle this problem in the future. So starting with the neurodevelopmental issues that really come along with prenatal stress. In all of the research done on the embryonic neurodevelopment, we've only been able to do animal trials, and that's for a couple reasons. Most importantly, we don't really have the technology or the capacity to be able to do this on human beings. For one, I don't think a lot of moms are going to be okay putting themselves potentially at risk for the sake of this research when they're carrying their child. And on top of that, the human gestational period is just way too long. It's 9 months. It would be somewhat impractical to be able to measure the effects of prenatal stress in such a long time span. The other thing is that rodents are actually very similar to human beings in gestational terms. The week before giving birth in rodents is roughly equivalent to the second trimester in human beings, and the week after birth in rodents is relatively the same as the third trimester in human beings. So we get a very good picture of what neurodevelopmental problems would look like in human beings due to prenatal stress in rodents, and we can abstract it to the human population. So the first thing I want to talk about neurodevelopmentally is that prenatal stress has been shown to inhibit the development of insulin receptors in these rodents. Particularly in the second trimester, what is seen with the insulin pathology was severely disrupted due to prenatal stress, which then predisposes these rodents and would predispose human beings to certain cognitive impairments, insulin resistance in adulthood, and even the potential of Alzheimer's much later in life. What was encouraging about this finding, though, is that it was only limited to the second trimester, and if you could somehow just pick the rodent up and put it into a stress-free environment in the third trimester after it was born, a lot of the damage done because of prenatal stress was actually reversed. So this is encouraging in the potential of human beings, if they were exposed to prenatal stress in the second trimester, suppose the mother moved to more favorable circumstances after the fact in the third trimester, perhaps a lot of the damage done would be reversed. The second very important neurodevelopmental finding in rodents was that prenatal stress significantly increased the amount of pro-oxidants in the embryonic forebrain. Particularly hydrogen peroxide was found in abundant amounts in embryonic forebrains when they were exposed to prenatal stress. Mothers somehow or another are able to detect this overabundance and send their own antioxidants into the embryo's forebrain to try to mitigate some of the problems. It's not enough to really counteract the entirety of the issue, but it does help a little bit. But when we look at an excess of hydrogen peroxide in the embryonic forebrain, there's a couple problems. One, again, it raises the potential of severe cognitive impairments but more importantly, it significantly increases the chances of autism spectrum disorder and even attention deficit hyperactive disorder in the adolescent period and the childhood period of the offspring. So those are just the two main findings that we've had, the really significant ones in rodent research into prenatal stress. But like I said previously, most of the research done in humans has been in the offspring, not so much the prenatal stages. And one of the things that was found, just more on the physiology side, was found in a rural Ghanan birth cohort. What they found was that the male offspring was relatively unaffected by prenatal stress. For the most part, there was no significant physiological difference between male offspring exposed to prenatal stress and male offspring not exposed to prenatal stress. However, there were significant differences in female offspring who were exposed to prenatal stress as opposed to female offspring who were not exposed to prenatal stress. Some of the consequences that we saw from prenatal stress were a much lower birth rate, a smaller head circumference, and a shorter body length for these female infants exposed to prenatal stress. The main issue with that is those are all key barometers in infant mortality rates, suggesting that female offspring who are exposed to prenatal stress have much higher infant mortality rates than those not. Now, keep in mind, this is particular to rural Ghana, which is very different geographically than other areas. But if this is to carry over to other societies, this raises significant questions about how we can further mitigate infant mortality rates. So then the other physiological problems associated with prenatal stress were found in Queensland, Australia. There was severe flooding in Queensland, Australia in 2011. So researchers took the opportunity to see what would happen to offspring exposed to disaster-based prenatal stress, like a flood. Again, they found that boys were relatively unaffected physiologically by prenatal stress and that females were significantly affected by it. In this case, they didn't look so much at birth weights and stuff like that. Instead, what they found was that at 16 months, females exposed to prenatal stress were significantly impaired in their motor skills. They just were not on par with the rest of the group. So when you combine all those factors, it's very clear that females exposed to prenatal stress are at risk of severe physical debilitations and limitations later in life, simply because they were exposed to prenatal stress. We don't know why it only affects female offspring physiologically, but we know that it does, and that's something to keep in mind as we move forward. And then lastly, and this is really the most documented part of prenatal stress, the most documented consequences of prenatal stress, is psychological disorders. So there was a Finnish birth cohort in which they allowed mothers to self-report their levels of prenatal stress from mild to moderate to severe. If they were experiencing no prenatal stress, they were kind of the control group. In cases of mild prenatal stress, it was found that the offspring were 3 times as likely to develop a personality disorder. In cases of moderate prenatal stress, they were 5 times as likely to develop a personality disorder. And in cases of severe prenatal stress, they were 7 times as likely to develop a personality disorder. So we, right off the bat, see extreme increases in psychological disorders, particularly personality disorders, just due to prenatal stress. And this was somewhat further advanced in a meta-analysis done of 217 different studies in prenatal stress. And across all of the different studies, what they found was very similar results for autism spectrum disorder. What they found was that there was a 64% increase in autism spectrum disorder just due to prenatal stress. And that even further, there was a 48% increase just when prenatal stress was present only in the 3rd trimester, further suggesting that that 3rd trimester is really an important time for prenatal stress to either be present or not present. And then lastly, what is important to note is that the scientific community is not entirely united on the front that prenatal stress is what causes these psychological disorders. There is a Norwegian birth cohort in which they found that it wasn't so much that prenatal stress was causing these abnormalities, but instead what it was doing was increasing neural plasticity. These neurons in these offspring were just more plastic. They were more malleable to the situation. And they suggested that the rise in these psychological disorders was actually due to the fact that they had heightened neural plasticity in poor situations. So their body was just adapting to these poor situations, and that's what was leading to the rise in developmental disorders, not so much that it was the prenatal stress itself. So with all these things in mind, a few questions have to be asked, but the main one is where does the study of prenatal stress go forward? The main problem with research in prenatal stress up to this point has been twofold. One, geographic differences have just not really been accounted for thus far. As I noted earlier, Ghana has a very different landscape and economic prosperity status than most of the world. Compare that to Australia, Finland, and Norway. How can we reasonably abstract takeaways from each study and apply them to the different populations? We just simply can't. Economically, they're just too different. Demographically, they're just too different. In order to really unify them into some complete theory, we don't have enough data to effectively do that. And lastly, the problem that should be a little bit easier to fix is that we don't really have a true measurement system for prenatal stress. We have a good definition, that low or negative quality of life while pregnant, but like I said, we had that one Finnish birth cohort where they were just allowed to self-report. They were just given 3 different adjectives and said, hey, tell us what your levels of prenatal stress are. That's not a very effective way. And then in the Norwegian birth cohort, again, they didn't really have a great measuring system. It is, again, just self-report based on different adjectives. So with that in mind, we really need to come up with a unified scale of prenatal stress so that it can be applied to every single study to kind of eliminate that heterogeneity of, within the studies. And that's the one thing that really will push the study of prenatal stress forward, is being able to find a way to unify all the different fields. One step will be moving on from rodent studies into different animals. That's going to help us a lot, especially once we get into primates if we can. That'll give us a much better picture of the human brain. The other, like I said, will be smoothing out the geographic and economic differences among studies. And then lastly, like I said, it will be coming up with that unified scale. So thank you for your time. I'm Mark Kokoropoulos.